So we're going to be separating our DNA by size using gel electrophoresis. Now, gel electrophoresis, the gel part stands for the gel, the gelatin-like material that we are going to be making for our DNA to move through. The other part, electrophoresis, implies that we're going to be using electricity. And the way the DNA is going to move through that gel matrix is by putting an electric current across our gel, and the DNA is going to move. So the DNA, under the conditions of our experiment, is going to be negatively charged, and it's going to move towards a positively charged electrode that we set up. And larger molecules will move more slowly through the gel than smaller molecules. So the smaller molecules should be farther away from where they started at the end of our experiment. Now, to get the DNA under the right conditions and to enable the electricity to move through our gel, we need to have a solution called a buffer. So the buffer is going to provide charged particles to carry the electrical current for us, and it's also going to have the correct pH for the DNA to be negatively charged. Now, pH is just a measure that chemists use to determine how acidic or basic something is. So acids are things that taste sour, like lemon juice or sour candy or orange juice. And things that are what we call are basic are things like soap or ammonia, things that you clean with. And so the pH scale tells us, how chemically where our solution stands on that spectrum. So in order to make the buffer, okay, you're going to need the baking soda from your kit, and we're going to be using as our buffer material sugar-free lemonade, because this actually has in it something called citric acid, which is a chemical that molecular biologists and biochemists will use in the lab to make these buffering solutions. And so the easiest and safest way for us to get it to you is to use some lemonade mix. And you're going to be needing your large beaker, and you're going to want to put 500 milliliters of water into your large beaker. So I had already measured this out, so I'm going to be putting that in. Okay, now we're not going to use this entire packet of lemonade mix. We want to measure out 4 grams of the lemonade mix. So I'm going to measure out 4 grams. And hopefully I'll be able to tear this packet open. Yep. And for this, I can just very carefully pour into my weigh boat. So we need 4 grams. Half of it now. So this experiment is going to smell pretty nice because of all the lemonade mix that we're using. And there we go. I have about 4 grams of my lemonade mix, and I'm going to put that into my water, and then I'm going to measure out 5 grams of baking soda. So I'm going to tear my balance with the weigh boat on it so that my weigh boat reads 0. And then I'm going to carefully measure out 5 grams of baking soda. So the lemonade mix is acidic and the baking soda is basic. And we're having you weigh out just the right amounts so that when you mix the solutions together, they will be a neutral solution. They'll be somewhere halfway between acidic and basic, and they'll be about the pH of water that you usually would drink. All right, so I have 5 grams of my baking soda, and I need to add it to my solution of lemonade. I'm going to stir the lemonade mix to dissolve it. I don't want to add this all at once, because what happens is I will get a chemical reaction occurring between the acid that's in the lemonade mix and my baking soda. And my baking soda, when it mixes with the acid in the lemonade, it creates carbon dioxide gas as a product of that reaction. So we're kind of making lemonade flavored soda here, but those bubbles will make your solution bubble over and spill if you add it all at once. So we want to add a little bit at a time and just keep stirring till everything dissolves. So, and oh, you can hear, well, you may not be able to hear, but right now I have a little sizzling that's going on, and I felt a little breeze from the gas that was coming up. So I almost put too much in there because some bubbles were about to make my thing spill over, but just a little bit at a time, let it dissolve so that those bubbles can dissipate and go away before your solution gets overly carbonated. So if you look at your solution when you're making it, you'll notice that, you know, it's got some bubbles in it, and again, it looks like soda. All right, almost there. So you're doing a little chemistry here with your molecular biology. All right, once you have all of the baking soda mixed in with the lemonade, and your solution seems to have stopped sizzling, and everything seems to be dissolved, you're going to want to just check the pH, okay? So what we have are these pH test strips, and the way that you use these is you take one of those pieces of test paper, and they will change different colors at different pHs. So I have a test strip here that I've taken out of my bag, and I'm just going to dip the end into my solution, and it's hard to tell. I'm going to bring it up closer to the camera. You'll see that it is kind of turned a greenish color, and what you want to do is you want to match it to the scale that's on here. So as you can see, my solution is close to being pH 7. It's maybe a little bit darker green than the pH 7, but it's definitely lighter than the pH 8. So as long as it's close to the pH 7, you're good. If your pH value winds up being a little too high, you can add a little tiny bit more of the lemonade powder, mix it in, test it again. If it's a little too low, if it's you know, sort of yellow or orange, then you can add a little tiny bit more of the baking soda, but you only want to add little tiny bits at a time. Now, if you weighed out your baking soda and your lemonade mix carefully, then your pH should be 7 when you test it, and you won't have to add anything else, okay? So you can use these pH strips to test things in your house, like your favorite thing to drink, or the shampoo that you use on your hair, okay? So now you have your buffer. And we're going to use it for two things, okay? The first thing we're going to use it for is to make our gel, okay? And so in your container that has your electrophoresis supplies, there's something that looks like this. And this is called a well comb. So you want your well comb, and then you also want your glass petri dish. So the next thing we're going to do after we've made our buffer is we are going to pour our gel. What that entails is weighing out some agarose powder and then mixing it with a little buffer and heating it up to melt it in the microwave, okay? So what I'm gonna do is I need my medium-sized beaker, my 200 milliliter beaker, okay? And I'm going to need to have about 70 mils of my buffer solution in here. So just so that it's easy to see on the video, I'm going to mark where 70 mils is on my beaker. And I'm gonna pour 70 mils of my buffer solution into, and I'm gonna hope I don't spill. It's okay if I do though. Okay. All right, I went a little over, so I'm just gonna pour a little bit back. Okay, I've got 70 milliliters now of my lemonade into my medium-sized beaker, and I'm going to weigh out 0.7 grams, 0.7 grams of agarose. So if you go into your electrophoresis kit again, you should have a small microfuge tube that it says agarose on it. Okay, so agarose is that material that we get from seaweed and things. It's something that's purified from seaweed and things like that. And we're going to dissolve that in our lemonade mixture and heat it. And when it cools, it's going to form a jello-like make substance. All right, so I'm just going to weigh out 0.7 grams of that. And there should be, whoops, I went a little bit over, but that's okay. And so that agarose is now going to go into my 70 milliliters of lemonade. Now, this, you can take your spoon and you can stir it, but it's not going to fully dissolve, okay, until we heat it up. So what I'm gonna do is I'm gonna take this over to the microwave and I'm going to heat it in 15-second intervals, okay? And every 15 seconds, I'm gonna take it out of the microwave and swirl it around a little bit. And when my solution finally gets to boiling, okay, then it's done cooking, okay? So before I take this to the microwave, I'm gonna set up my gel casting stand here. So you're done with your scale now at this point, and we can set it off to the side. So we're going to be pouring our gel mixture into our plate, our glass dish. And what you want to do is you want there to be some wells at one end of your gel. There'll be little depressions or little holes in your gel where you're going to be able to put your DNA, okay? And so the thing that is going to make the holes in the gel is this thing right here that we call the comb. So before we pour that liquid gelatin into our dish and let it set and harden, we want the comb to be in there. And so you're going to want to place your comb at one end of your dish like I have here, and you'll know that it's at a good position if you take your ruler and you measure. If it should be about an inch from the edge of the dish, maybe a little bit less than an inch, but anywhere from 2 centimeters on is good. Okay. All right, so I have my comb balanced on the edge of the dish. Now I'm going to go to the microwave and heat up my gel mixture, and I'll be right back. I'm back from the microwave. So in my microwave here in the lab, it took me about 45 seconds to get my solution to boil. And it's boiling when it's sort of really bubbling. You have the little bubbles that are still that carbon dioxide from the mixing the baking soda and the lemonade powder, but it will be sort of really big bubbles when it's boiling. You just want to swirl it a little bit. You can leave the base of the beaker on the table and just kind of move it around in a circular motion. And once it's well mixed, it's ready to pour into our casting stand. So you're going to pour all of that liquid, okay, into, and just pour it slowly. All right. So at this point, we're going to set this aside, and we just want to let it to cool and harden. So I'm just going to carefully slide this over to the side so that we can start the next part of our experiment. Okay. All right. So once that cools and hardens, we'll be cutting the gel into a rectangle, and then we'll be getting ready to load it into our gel box and to run our gel. So while your gel is cooling, we're going to build our next piece of equipment. And the piece of equipment that we're building is our gel box. So you're going to take your plastic bin from the kit and take the lid off, and everything that's in that kit, you've got the pH test strips, you can put those into the lid of the box. We need everything out of the box. So the batteries we can take and put on the table, okay? The little tubes that have different materials in them, we can put in our test tube rack, okay, in our microfuge tube rack. We have a couple of extra microfuge tubes. Those can also go in your rack. You can take out the wires, the electrodes, and there's a piece of aluminum foil that's in there. So now I have an empty box, okay? And the first thing we're going to do is we're going to make our electrodes, okay? So unfold the aluminum foil. So what we were doing is we're going to make our electrodes, those things that are going to be helping to run the current, the electrical current through our system. We're going to make them out of aluminum foil. So you have a large piece of aluminum foil here. And what you need to do is you need to cut it in half the long way for us to make our two electrodes. So what I'm going to do is I'm going to grab a pair of scissors. Got my scissors. And I'm going to just cut this in half a long way, okay? It's okay if you're not that great at making a straight cut. You can follow the fold line, that helps. Okay, so now I have two pieces, and what I need is I need to fold these over so I have, my electrode is made out of multiple layers of aluminum foil. So I'm going to fold this in half once. And again, I'm going the long way because I want to make my electrodes long. So I fold it in half once so that it looks like this. And then I'm going to fold it in half again. So I'm just going to match the long edge up. And once I'm done, okay, I have an electrode that I can check with my ruler. If I can find my ruler, here's my ruler. And my electrode, this electrode is roughly 2 centimeters wide. I can fold it over again. I just need a 1 centimeter wide electrode. So we may have been extra generous with the amount of foil we gave you, but the more layers you have in your electrode, the better off you are. So, all right, so I've folded it in half the long way 3 times over. My final electrode is about 1 centimeter wide. So I'm going to repeat this with my other piece of foil. So I'm going to fold it in half. So this is the fun part for people who are crafty. People who like to cook, making the buffer was the fun part. It's all fun to me. Science is fun. We get to play with things. Okay, so I folded it over a second time. I have a wide strip. I'm going to fold it over one more time. There we go. All right. So I have 2 electrodes. So those are my electrodes. Now I need to make the power supply that's going to supply power to my system. And we're going to make that out of 5 9-volt batteries. 1, 2, 3, 4, 5. Now, those of you who have a sibling that are attending the camp, you have extra batteries in your kit so that you might be able to actually run 2 gels, so run it twice. So what we're going to do is you're going to put 3 batteries together, okay, and then you're going to attach the 2 other batteries upside down to those, okay? So you'll notice that the tops of the batteries have a round knob and a hexagon-shaped knob, okay? So what you're going to do with the batteries that you set up on the table is have them so that the round part is on the left and the hexagon is on the right, for all of them, or so that they're all lined up kind of with the round part on the same side. Then you're going to take the other 2 batteries and you're going to attach them to the bottom batteries, okay? So you're going to fit the round knob into the hexagon-shaped hole, and the hexagon is going to fit the bottom's round knob, okay? Okay. So now what I've assembled is a 45-volt power pack, okay? And you'll notice if you look at the sides of the batteries, okay, there's a plus sign on the bottom battery on one side, and there's a minus sign on the other, okay? So the minus sign is by the hexagonal knob, and the plus sign is by the round knob. That plus sign, okay, we want to have, we're gonna set that up to be attached to our plus charged electrode, okay? So right now what I did is I put my plus side, you know, facing on the right here, okay? And I'm gonna attach my wires now, okay? So I've got my batteries connected, okay? And I'm gonna take my black wire, okay? That is going to be attached to the negative side, so the minus side, and you wanna squeeze the ends of, this is called an alligator clip, and you want it to pinch onto that side of the power supply, okay? Then my red electrode, or my red wire, I'm going to attach to the positive side, okay? Now, once I have those attached to my batteries, I don't want these ends to touch, and I'm just going to kind of set those aside for now, okay? So there's my battery, my power supply. It's all ready and waiting for me to have a gel that's ready to go, okay? So to get the electrodes into my tank, which is what we're calling this black plastic Tupperware, this is our electrophoresis tank, okay? So to do that, what we want to do is we want to have those electrodes in our black plastic bin. And so what I want to do is put the piece of foil, okay, so that one end is kind of just up against the edge of the plastic container, and then I want to fold the rest of it, okay, so that it's kind of attached to my plastic container, okay? So this is going to be my negative electrode, okay? And my positively charged electrode is going to be at the other end. So the first thing to do is just to get both of them set up into your tank. And again, use the fact that it's a metal foil and that you can bend it and you can have it really kind of hold on to the edges of that plastic container, okay? So right now, that's what my tank with my electrodes looks like. Now you want these to be, about 14 centimeters apart. So you can take your ruler and it's roughly, having them one on either end where the side of the electrode lines up with the kind of ridge in this black plastic container, okay? So now I have my electrophoresis apparatus all set up, and it's just ready and waiting for me to have a gel to put into it and to load.